Alright, so I went ahead and copied down everything the LeetCode tells us. Basically, we're given two sorted arrays of size m and n, and we're told to find the median of the two sorted arrays, and we're also told that our runtime must be O of log m plus n. And immediately when we see log of n plus n, we should start thinking about the algorithms that we know that have that runtime. And that can really narrow down our thinking when we're thinking about what algorithms to use. And so we're also told we can assume that nums1 and nums2 cannot both be empty, and that's just to make things easier on us. And so first, let's think about what the median actually is. It can kind of be split up into two different cases. The first case being we're given an odd number of numbers. And in this case, what we're going to try to do is we're going to find a partition of the list such that one side has one extra element on it. And so in this case, we have 3 elements on this side and 2 elements on this side. And so because the left side has one extra element on it, we know that the median will be the number found directly to the left of the partition. The other case is we're given an even number of numbers. And in this case, what we're trying to do is find a partition such that there are even number of numbers on each side of our partition. And so we could start having our partition here, but there are not an even number of numbers on each side because this side is 1 and this side is 5. So we'll continue moving our partition until we get to here. And now we see there are 3 numbers on this side and 3 numbers on this side. And so we know that our partition's in the right spot. But for when we have an even number of numbers, we can't just say that the median is the number directly to the left. We have to say the median is the average of these two numbers. And in this case, it would be 8 plus 9 over 2 equal to 8.5. Alright, so this is the first example that we're given by LeetCode. One array has 2 elements and one array has 1 element. And so let's think about what it would look like if we just did the brute force method of combining these arrays and sorting them. We would have an array that looks something like this. And to find the median, first we see that because it has an odd number of numbers in it, we're going to do the method of finding the partition that separates the array such that the left side has one extra element when compared to the right side. And so this would be our partition. And then, because it has an odd number of numbers, we say the median is the number directly to the left. Well, that's great, but the runtime of combining 2 arrays will be greater than our required runtime bound. And so let's think about how to use this concept and apply it to 2 separate arrays. We see that here, the partition is directly to the right of the 2 for nums2. And respective to nums1, the partition is directly to the left of the 3. If we were to combine these arrays, we would have 2 elements to the left of our partition and 1 element on the right. And so that satisfies our requirement of the left side having 1 extra element at the right. And so in this case, instead of saying the median is the number directly to the left of our partition, because we have 2 arrays here, what we have to do is say the median is equal to the max of the number directly to the left of the partition in nums1 and the number directly to the left of the partition in nums2. In this case, it's the max of 1, 2, which we know is equal to 2. And so that's going to be the general algorithm for trying to find the median. Let's take a look at another example. Alright, so let's take a look at a harder example. Right off the bat, we see that the combined length of both of these arrays is going to be an even number, so we're going to have to use the technique of averaging the 2 middle numbers. Now, let's try to find our partitions. I think an easy way to start is to just make a partition in the middle of X. So we have 2 elements on the left here, and so we need to find a partition in the right in Y that also has 2 elements to the right of it, which is this one. And so now we have partitions that satisfy 2 elements on each side, and we could just try to take the median of this. And so we're going to take the max of these 2, the min of these 2, divided by 2, that's 1. But let's take a look at how the array would actually look. with our partitions. And so now let's draw in the partitions that we found using our naive guess. There's this one is between the 2 and the 9. And this one is between 2 zeros. Right off the bat, we see that our partitions divide our array into 3 groups, which doesn't make sense. And also looking here, we see that it doesn't make sense because if we draw the correct array with the partition, we see that it should be partitioned directly down the middle, and so we should be taking the average of 1 and 2. And so we need to introduce a new condition so that we can fix this and bring both of our partitions closer. And now let me write out that condition. And so looking at our condition, we see that the number to the left of the x partition, 2, must be less than the number to the right of the y. And in our case, it's not. And so we also need to satisfy that the number to the left of y must be less than the number to the right of x, which we do satisfy. So let's try to fix this condition being wrong. To make left x not be greater than right y, what we're going to do is we are going to essentially shift this partition here, and by doing that we will shift this partition here. And now we can see, is the number to the left of x less than the number to the right of y? Yes. Is the number to the left of y, 0, less than the number to the right of x? Yes. And now we can do our algorithm from before, which was just taking the max of these two numbers, which will be 1, plus the min of 2 and 2, which is 2, divided by 2 equals to 1.5, which is the correct median. All right, so now that we've written it out, let's start coding it. The first thing we're going to do is see what array is bigger, because we want to be scanning through the smallest array to save us time. If nums1 is larger, we're going to make a temp and basically swap the references. Now that we are certain that nums1 is the shortest array, we can start doing our binary search setup. Low equal to 0, int high equal to nums1.length. And because we know that we need to see if the combined length is even, we're going to also grab the combined length. And that's just the sum of both lengths. All right, so now let's do our binary search. While low less than or equal to high, we're searching for the correct partition. And our partition for x will be this, part x, and that's equal, we'll start out in the middle. And then we know that part y is determined by part x. And so it's going to be the combined length plus 1 over 2, subtracting the partition of x, because we want to make sure that there's an equal number of elements as there is on the left of the partition of x. All right, now that we've done that, we are going to get to the number that is directly to the left of our partition in each array. And so here, if our partition was between 1 and 2, we want to get 1 to be the int left x. And I'm going to right now define a method called getMax of nums and the partition of x. And let me explain why. So we can't just grab the number that is directly to the left of our partition, because it's possible that our partition could be here at the very beginning of the array. And think about what would happen if we tried to grab that number to the left of here. We'd get an exception, and we don't want that. And so basically we're going to define a different method. It's a private helper called getMax that's going to return an int. And all it's going to do is take in the array and the partition. It'll check if the partition is equal to 0. And if the partition does equal 0, we're going to return a really small number. And we do this because we don't want to potentially say it, like if we said return -1, what would happen if this array was composed of numbers all smaller than -1? It would mess up our results and we would return incorrect answer. So we need to think of the smallest number we could think of, which is -infinity. And I'm going to cast it because the only way we have access to it is by a double. If the partition isn't equal to 0, we can simply return the number to the left of that index. We're also going to need to get the number to the right of x. And if we remember to the written solution, if our partition is directly in the middle right here, where my mouse is, we take the min of these two numbers. So I'm going to define a very similar method called min, except it's going to return positive infinity if the partition is equal to the length. So if we're on the total right side, the end of the array, and otherwise, we just want to return nums of partition. Now that we've defined those, we go ahead and minimize them, make it look a little bit cleaner, and we're going to do the exact same thing for the left of y and the right of y. And I just now realized I need to be saying nums1 and nums2 for the respective arrays. All right, and now this is pretty much the gist of what we're going to be doing. We just need to check if we satisfied our conditions that we wrote out. So if left x is less than or equal to right y, and left y is less than or equal to right x, then we know our partition is in the right spot. So we're going to say we need to get the median. And remember, there's two cases for the median: when it's even, when we're given an even amount of numbers, and an odd. And so if combined length is even, or mod 2 equals 0, we are going to return the average of the two middle numbers. And we get the two middle numbers by saying max of left x, left y, plus the min of the two on the right, just like when we were writing it out, divided by 2. And because this will give us integers and we're expected to return a double, we're going to divide by 2.0, so that'll automatically cast it to a double. All right, otherwise, if combined length is odd, all we need to do is return math.max of left x and left y. All right. And now, if we're in the case where our partition is not correct, we need to adjust our partition accordingly. And so we're going to say if left x is greater than right y, then we need to shift our high down 1. So we're going to say high is equal to partition of x minus 1. Else, we know we need to shift it up, so we're going to say low is equal to part x plus 1. I just realized I forgot to type a 1. And now, this will work unless we're given an unsorted list. And so here we can return anything or throw an exception. I'm just going to return -1 to show that it is not a correct answer. And so now let's see how this works. And we're getting a compiler error because on line 15, and there we go. So we've come up with a decently fast solution, and I hope it makes sense to you. If it doesn't, I encourage you to go back and look at the part where we wrote it out, and hopefully it'll make more sense if you watch that again. And so now let's think about the time complexity of this code. And yeah, that's how you would do the find median of two sorted arrays question on LeetCode. If you have any questions, leave them in the comments. The problem is in the description. And as always, have a great day.